Alright, we're not going to really look at this tracing the program thing. They start at the beginning. The ability to trace execution, so sure, but we're just they're just tracing the output and looking at each spot, but we're not going to worry about that. So we're looking at 7.7 and the counting digits. Now, one of the things I wanted to point out here is that as far as just deciding how big a number is, you don't actually really need a loop at all. But let's take a look at this one, and then we'll try doing it without a loop. So we'll put our definition here, and so we'll just have it print the num digits of, let's say, 1, 2, 3, 4. So 4 digits. And run that, and sure enough, it got 4 digits. And as we look at what happens here, again, when you get the number, you don't know how many times you're going to have to go through it, because you don't know how big the number is. But notice they just start the count at 0, so they initialize it. Then they go in here and say, well, n is not 0, and so see they're updating n every time here. So while it's not 0, we're going to add 1 to the count because we came in here, so that's 1 more, or one digit. And if we take the number and divide it by 10, so think about that, we've got 1, 2, 3, 4. Integer divide by 10, and so we'll just get 1, 2, 3, and so it'll go up, and it's not 0, so it'll say, okay, let's make the count 2, divide by 10, that'll give us the 1, 2 is left, so 12. Well, 12's not 0, so we come in, add another one, this makes 3, we take 12 divided by 10, we'll get 1. And because it's integer divide again, so we get 1. We come up here, 1 is not 0, so we add another one, that makes 4. Then we take 1 divided by 10, well, that is 0, and so when it comes up, it'll be done, and it will return 4. Now I think we can do the same thing. We'll have to import math, I think. So let's import math. I think it's just math. And so now down here, if you use log base 10 on a number, so we're going to do this. We're going to do print, and we're going to do math dot, it's log, we'll see, I could be wrong, and we're going to take the base 10, so I'm going to say n and then a 10 for base 10, and so for instance 100 is 2, log of 100 is 2, because 10 times 10, or 10 squared, is 100. Log of 1000 is 3. And so what happens is when I take the log of this number, and we'll just start there just to kind of see what we get, see if it works, but what we'll get is if it's in the hundreds somewhere, we'll get 2 point something. If it's in the thousands somewhere, we should get 3 point something. And so let's we'll stick with the 1, 2, 3, 4. See if it runs. Oh, no. Okay, n is not defined. Oh, n was only in the definition. Okay, so let's do this. We'll do an uppercase N for the fun of it, and we'll say that's 1, 2, 3, 4, and N, and then I'll do an uppercase N here. We could do a lowercase n, but this is just to make sure we see they're different. Because again, this n is a local variable. So let's try that again. And so you see, we got 3.09. Now what I can do is, if I cast this to an integer next, so I'll say int, and add that. So this time it should give me a 3. And it does, a nice 3 there. And so what we see is it's going to give me 1 less than the actual number of digits. And so without even using a loop, I can then just add 1 to that and run that, and we get 4 that way. So you don't actually need a loop to do this, but this is a nice loop up here, dividing by 10 each time and keeping track of it. So that's kind of a nice way to do it. Let's go back then to this, and next it says, well, what if we only want to count certain digits? Okay, we only want to count the number of digits that are either 0 or 5. Okay, adding a conditional before incrementing the counter to do will do the trick. Okay, so what they do is they first take n, and they do a remainder, n divided by 10. So for us, that would be, we would get 3, what was our number? 1, 2, 3, 4. So we would get a 4. Okay, so we would get a 4 because that's the ones digit. And it says if digit equals 0 or 5, then count it. Okay, so this is, by doing the remainder when we divide by 10, that gives us the last digit of the number, and so then we check it to see if it's 0 or 5, and we count that, and then we update and do it again. So the difference is simply that, well, we had to really use both of these. Use this to get what the ones digit is, and then this to check whether we really want to count or not, and then this other is the same. And so we can add that to our definitions. So after this definition, and in style, they said, put 2 lines in there. And so, I can change this to the number of 0s and 5s, and for our number of 1, 2, 3, 4, we should get 0. Okay, and 0 it is. So again, though, because we don't really know how big the number is before we start, a while loop makes a lot of sense for this. So that's 7.7, and we'll stop this there.